In the winter of 1940, as German forces celebrated their conquest of Europe, Luftwaffe officers gathered around intelligence photographs in Berlin and burst into laughter. The images showed America's latest military aircraft, crude-looking machines that seemed more like flying tractors than weapons of war. These were men who commanded the world's most advanced air force, flying precision-engineered fighters that had dominated European skies, and they couldn't imagine these primitive American designs posing any threat. What they didn't realize was that across the Atlantic, American factories were preparing to unleash an industrial avalanche that would bury German aviation excellence under millions of wings. The Reich Air Ministry building towered over Berlin's government district like a concrete monument to German aviation supremacy. Its imposing stone facade, carved with eagles and swastikas, housed the headquarters of what many considered the most advanced air force in history. On a cold February morning in 1941, intelligence officers gathered in a mahogany-panelled briefing room on the building's third floor, ready to examine the latest reports from across the Atlantic. Photographs were spread across the polished conference table, like evidence in a criminal case. The images, obtained through German intelligence networks operating in American aircraft factories, showed the United States Army Air Force's newest acquisitions. What the assembled Luftwaffe officers saw made them struggle to maintain their military composure. The Curtiss P-40 Warhawk dominated several photographs, its awkward proportions immediately apparent. The aircraft's nose seemed too short, its landing gear too high, its overall design reminiscent of something cobbled together in an agricultural workshop rather than an aviation facility. One colonel picked up a photograph and squinted at it, as if closer examination might reveal some hidden sophistication that wasn't immediately obvious. The Bell P-39 Airacobra provoked even greater amusement. Its engine was mounted behind the pilot, a configuration that violated every principle of fighter aircraft design that German engineers had spent decades perfecting. The cannon firing through the propeller hub seemed clever in theory, but the aircraft's ungainly appearance suggested practical problems that would plague its combat effectiveness. Most ridiculous of all was the Republic P-47 Thunderbolt, a massive, bloated fighter that seemed more suited to hauling cargo than engaging in aerial combat. Oberst Werner Mulders, one of the Luftwaffe's most decorated pilots, held up a photograph of the P-47 and shook his head in theatrical disbelief. "Mein Gott," he muttered loud enough for the room to hear. "The Americans expect to fight the war with flying freight cars." The room erupted in knowing laughter. These were men who commanded sleek Messerschmitt Bf 109s, aircraft so precisely engineered that every component served multiple purposes. They had watched their fighters tear through Polish PZL aircraft like hawks among pigeons. They had seen Focke-Wulf 190s dominate the skies over France with technological superiority that bordered on unfair advantage. The notion that these crude American contraptions could pose any meaningful threat seemed genuinely absurd. Technical specifications reinforced their confidence in German superiority. Intelligence reports indicated that the P-40's Allison V1000 710 engine produced approximately 1,040 horsepower, pathetic compared to the Daimler-Benz DB 605 powering their latest Bf 109, variants with 1,475 horsepower. American construction techniques appeared primitive, with riveted aluminum panels that looked hastily assembled rather than precision crafted. General Major Adolf Galland, the Luftwaffe's youngest general and a veteran ace pilot, leaned back in his chair and lit his trademark Cuban cigar. The ritual was familiar to everyone present. Galland's theatrical gestures had become legendary throughout the German Air Force. "Gentlemen," he announced with characteristic flair, "it appears the Americans have confused aviation engineering with farm equipment manufacturing. Perhaps they're planning to harvest wheat with these flying tractors." The laughter grew louder, echoing off the room's high ceiling. What made their mockery so confident was their own unprecedented track record of success. The Luftwaffe had revolutionized aerial warfare through precision engineering and tactical innovation. Their Messerschmitt Bf 109, with its fuel-injected engine and sophisticated aerodynamics, represented the pinnacle of aviation technology. Each aircraft required over 5,500 man-hours to construct, with components machined to tolerances that would satisfy Swiss clockmakers. German pilots underwent months of intensive training on complex aircraft systems, learning to extract maximum performance from machines that embodied decades of aeronautical research. The Luftwaffe approach emphasized individual excellence, each pilot a specialist, each aircraft a precision instrument designed for specific tactical roles. Their recent victories validated this philosophy completely. Poland's air force had been destroyed in days, overwhelmed by German technical superiority and tactical coordination. The French Armée de l'Air had lasted only weeks longer, its pilots unable to match German training standards or aircraft performance. Even the vaunted Royal Air Force, despite fighting over home territory with shorter supply lines, had been battled to exhaustion during the previous year's campaign. The intelligence photographs represented everything German military doctrine considered fundamentally wrong with American thinking. Where German aircraft were specialized for precise roles, these American machines appeared to be crude compromises. Where German designs pursued aerodynamic perfection through years of wind tunnel testing, American aircraft seemed to prioritize manufacturing simplicity over performance optimization. One intelligence officer noted that American factories were reportedly planning massive increases in aircraft production. This information only added to German amusement rather than concern. Aviation manufacturing was an art requiring skilled craftsmen, precision tooling, and accumulated expertise spanning decades. You couldn't simply decide to mass-produce aircraft using automobile assembly techniques. The Americans were clearly attempting something beyond their industrial capabilities. As the briefing concluded and officers prepared to leave, still chuckling about American aviation incompetence, none could have imagined the industrial transformation already underway across the Atlantic Ocean. In factories stretching from Seattle to San Diego, from Buffalo to Fort Worth, American industry was preparing to demonstrate that German laughter was premature. The crude aircraft they mocked would soon darken European skies in numbers that would make individual excellence mathematically irrelevant. Their confident mockery would echo through history, not as validation of German superiority, but as a cautionary tale about underestimating enemies who were playing an entirely different strategic game. The contrast between German and American aviation philosophy was as stark as the difference between a handcrafted sword and a factory-produced rifle. Both were lethal weapons, but they represented fundamentally opposing approaches to modern warfare. German aviation embodied centuries of Teutonic craftsmanship and engineering perfectionism. Each Messerschmitt Bf 109 represented months of meticulous design work, with every component optimized to extract maximum performance from minimum weight. The aircraft's Daimler-Benz DB605 engine was a metallurgical masterpiece, featuring fuel injection systems and variable speed superchargers that delivered 1,475 horsepower with Swiss watch precision. Manufacturing a single Bf 109 required 5,500 man-hours of skilled labor. Master craftsmen, trained through Germany's rigorous apprenticeship system, hand-fitted components with tolerances measured in thousandths of inches. Cannon barrels were precision-bored to specifications that would satisfy chronometer makers. Even the aircraft's camouflage paint was applied in 7 separate coats, each chemically formulated for specific optical and protective properties. German pilot training reflected this same obsession with individual excellence. Luftwaffe candidates endured 18 months of intensive instruction, mastering not just flight techniques, but intimate knowledge of every aircraft system. They learned to diagnose engine problems by subtle sound variations, adjust fuel mixtures by tactile feedback, and extract performance levels that pushed their machines to theoretical limits. This philosophy had delivered unprecedented results across European battlefields. Luftwaffe pilots achieved kill ratios that seemed mathematically impossible, individual aces claiming hundreds of aerial victories. Their tactical innovations revolutionized air combat doctrine worldwide. The Finger Four formation maximized both offensive firepower and mutual protection. American aviation philosophy emerged from entirely different cultural foundations: industrial pragmatism rather than artisanal perfectionism. Where German engineers asked, "How do we build the ultimate fighter aircraft?" their American counterparts posed a fundamentally different question: how do we build 10,000 fighters that are good enough to win? The philosophical divide was immediately apparent in design approaches. The North American P-51 Mustang's initial blueprints were completed in just 117 days, a development timeline that would have horrified German engineers who spent years perfecting individual components. Early Mustang variants were indeed crude, plagued by engine problems that validated German assumptions about American technical incompetence. But Americans didn't pursue initial perfection. Instead, they embraced systematic improvement through rapid iteration cycles. Each production batch incorporated lessons learned from previous versions. Problems were solved through engineering modifications that could be implemented on assembly lines, not through painstaking hand craftsmanship that required months per aircraft. American manufacturing revolutionized aircraft production by applying Henry Ford's assembly line principles to aviation. Instead of master craftsmen individually fitting components, factories employed standardized parts that could be assembled by workers with minimal specialized training. Production tolerances were deliberately looser than German standards, but proved entirely adequate for operational requirements while enabling mass production. The training philosophy reflected this democratic approach to technology. Where Germany created aviation virtuosos, America mass-produced competent technicians. Flight schools processed thousands of candidates using standardized curricula and systematic instruction methods. Training emphasized reliable competence rather than individual brilliance, operational effectiveness rather than theoretical perfection. American aircraft embodied these practical design principles. Controls were simplified for intuitive operation under combat stress. Maintenance procedures were designed around field conditions rather than factory-equipped workshops. Complex systems were avoided in favor of robust solutions that could be repaired by mechanics using basic tools. The Republic P-47 Thunderbolt perfectly illustrated this philosophy. Despite its ungainly appearance that provoked German mockery, the aircraft could absorb battle damage that would destroy more sophisticated fighters and still return its pilots safely to base. Its massive radial engine, while heavier than German inline designs, proved remarkably reliable and maintainable under field conditions. These competing philosophies had served their nations well in different contexts. German precision engineering had overwhelmed Poland's obsolete air force through pure technical superiority. French aviation, hampered by committee-designed aircraft and demoralized production workers, couldn't match German standards in either equipment quality or pilot training. American philosophy was designed for sustained industrial warfare, rather than brief decisive campaigns. Mathematical implications favored quantity over quality in prolonged conflicts. Each German aircraft represented months of irreplaceable skilled labor. Every trained Luftwaffe pilot required 18 months of intensive instruction. American production lines operated continuously, replacing losses faster than combat could inflict them. Training programs graduated new pilots weekly using systematic instruction methods. Damaged aircraft could be repaired by mechanics who understood systems designed for maintainability rather than theoretical perfection. The fundamental question would soon be answered through combat testing. Which philosophy better understood modern warfare's true requirements? German craftsmanship pursuing individual excellence, or American industrialism emphasizing collective capability? Across the Atlantic, while German officers laughed at crude American aircraft, factories were preparing to demonstrate that sometimes victory belongs not to the most sophisticated solution, but to the most scalable one. December 7th, 1941 changed everything. The attack on Pearl Harbor didn't just bring America into the war militarily. It unleashed industrial forces that had been dormant since the Great Depression. Across the continent, aviation factories transformed from producing modest civilian aircraft into weapons of mass production. Boeing's Seattle facility epitomized this transformation. In 1940, the plant employed 4,000 workers building commercial airliners. By early 1942, that number had exploded to 50,000. The factory floor expanded beyond recognition, with assembly lines stretching across acres of hastily constructed buildings. Consolidated Aircraft's San Diego plant experienced even more dramatic growth. The workforce swelled from 8,000 to over 40,000 in 18 months. New employees arrived faster than housing could be built, creating sprawling tent cities around factory perimeters. Workers lived in trailers and hastily erected dormitories, united by the mission of turning raw aluminum into flying weapons. The transformation represented a fundamental shift in aircraft manufacturing philosophy. Traditional aviation production had relied on skilled craftsmen who understood every aspect of airplane construction. The new American approach broke complex assembly processes into simple, repetitive tasks that could be learned in days rather than years. Women entered the workforce in unprecedented numbers, their smaller hands proving ideal for installing intricate wiring harnesses and delicate instruments. Rosie the Riveter became more than propaganda. She represented millions of women working night shifts to keep production lines moving continuously. Teenagers too young for military service found purpose on factory floors, working after school and weekends. They carried messages between departments, organized parts inventories, and performed quality control inspections with enthusiasm that infected entire production teams. The psychological transformation matched the physical expansion. These weren't just jobs, they were personal battles against fascism. Every rivet driven was a blow against Hitler. Every aircraft completed meant American servicemen overseas had better chances of survival. Factory walls displayed production quotas alongside casualty reports from Pacific and European theaters, creating direct emotional connections between assembly line work and battlefield outcomes. Quality control evolved to match mass production realities. Where German factories emphasized individual perfection, American plants developed systematic processes, ensuring consistent adequacy across thousands of units. Statistical sampling replaced individual inspection. The goal wasn't perfect aircraft, it was reliable aircraft produced at sustainable rates. The numbers told an incredible story of industrial mobilization. In 1940, American military aircraft production totaled approximately 6,000 units, mostly trainers and obsolete fighters. By 1942, that figure had skyrocketed to 47,000 aircraft. The mathematical progression seemed impossible to German intelligence analysts who dismissed early reports as Allied propaganda. Training programs expanded dramatically to match production increases. Flight schools that had graduated dozens of pilots annually now processed hundreds monthly. Standardized curricula replaced individualized instruction. Synthetic training devices simulated combat conditions without risking expensive aircraft or irreplaceable instructors. Supply chains stretched across the continent, like vast circulatory systems feeding the production beast. Steel from Pittsburgh foundries, operating around the clock, aluminum from processing plants that had tripled capacity within months. rubber from facilities that had abandoned civilian tire production entirely. Thousands of subcontractors joined the effort, many having never produced military equipment before the war began. A typewriter manufacturer began making gun sights. A bicycle company started producing landing gear components. A kitchen appliance factory switched to manufacturing carburetors. Each represented American industrial flexibility and rapid adaptability. Companies that had been fierce competitors began sharing technical information freely. Patent restrictions were suspended for the duration. Trade secrets became common knowledge if they could accelerate production. Normal business competition gave way to collaborative efficiency, all focused on defeating fascism through overwhelming productive capacity. The economic impact rippled through communities nationwide. Towns that had withered during the Depression suddenly boomed as factories expanded. Unemployment, which had plagued America throughout the 1930s, virtually disappeared in industrial centers across the nation. German intelligence received reports of this production explosion and initially dismissed them as impossible exaggerations. Surely no nation could expand aircraft manufacturing at such rates while maintaining quality standards. When prisoner interrogations confirmed the numbers, German officers accused captured Americans of lying. The reality was becoming undeniable. America's sleeping industrial giant had awakened, and its appetite for aircraft production seemed unlimited. Factories were completing aircraft faster than Germany could train pilots to fly them. By late 1942, American aircraft were arriving overseas in quantities that began shifting the mathematical balance of air warfare. The laughter echoing through Berlin conference rooms was growing quieter as reports confirmed that American industrial mobilization was transforming from joke to avalanche. The mathematical reality was brutal for German planners attempting to understand American aircraft production capabilities. In 1940, the Luftwaffe operated approximately 4,000 aircraft, the largest air force in the world. American military aircraft production that same year totaled roughly 6,000 units, mostly trainers and obsolete fighters that German intelligence dismissed as irrelevant. By 1942, the numbers had shifted dramatically. American production exceeded 47,000 aircraft annually. By 1943, that figure climbed to 85,000. At peak production in 1944, American factories completed 96,000 aircraft in a single year. Germany's total aircraft production for the entire war barely exceeded American output in 1944 alone. The numbers became more devastating when maintenance factors were considered. German aircraft, while individually superior, required extensive specialized maintenance between missions. A Messerschmitt Bf 109 might complete 2 combat sorties before needing significant repairs by factory-trained technicians using precision tools and exact replacement parts. American aircraft were designed for sustained operations with minimal maintenance requirements. A Republic P-47 Thunderbolt could fly dozens of missions between major overhauls, serviced by mechanics using basic tools and standardized parts. Repairs could be completed by ground crews in field conditions rather than specialized facilities. Pilot training ratios told an equally stark mathematical story. Germany trained pilots in small batches through intensive 18-month programs. Each candidate received personalized attention from experienced instructors, learning complex aircraft systems through repetitive practice. The process produced excellent pilots, but at unsustainable rates. America created pilot factories, massive training facilities, processing thousands of candidates using standardized curricula and mass production techniques. Training emphasized consistent competence rather than individual excellence. The system produced adequate pilots at rates that overwhelmed German calculations. Fuel consumption created additional mathematical challenges for German forces. Their high-performance engines consumed aviation fuel at rates that strained synthetic production facilities. The Daimler-Benz DB605 engine required premium fuel that was increasingly scarce as Allied bombing targeted German refineries. American aircraft engines, designed for efficiency rather than maximum performance, operated effectively on lower octane fuels available in abundant quantities. The Pratt & Whitney R2-800 Double Wasp, powering the P-47, consumed fuel at rates allowing extended operations without compromising effectiveness. The replacement mathematics were perhaps most telling. When Germany lost an experienced pilot, replacing him required months of intensive training that consumed fuel, aircraft, and instructor time that German forces couldn't afford. Veteran pilots represented irreplaceable investments in human capital. When America lost a pilot, replacement pilots were already progressing through standardized training pipelines. Thousands of candidates were simultaneously learning to fly in facilities across the continental United States. The system produced replacement pilots faster than combat could eliminate them. Aircraft attrition rates favored American forces mathematically. German pilots flew superior aircraft, but each loss represented months of irreplaceable production time. American aircraft losses were quickly replaced by production lines operating continuously around the clock. German planners began grasping the scope of their miscalculation as intelligence reports confirmed impossible-seeming production figures. This wasn't about individual aircraft quality anymore. The conflict had become a mathematical competition between precision, engineering, and mass production, between individual excellence and systematic adequacy. Quality control mathematics also favored American approaches. German quality standards required extensive individual inspection and hand-fitting of components, consuming time and skilled labor that limited production rates. American quality control used statistical sampling and systematic processes, ensuring consistent adequacy across thousands of units. The strategic implications were becoming undeniable to German staff officers who understood mathematics. Individual aircraft superiority meant nothing when facing opponents who could replace losses faster than they could be inflicted. Pilot excellence became irrelevant when enemy formations contained more aircraft than German forces could engage simultaneously. Training facility mathematics compounded German disadvantages. Luftwaffe flight schools operated limited numbers of training aircraft, restricting pilot production to small sequential batches. American training facilities operated thousands of aircraft simultaneously, processing multiple classes of pilot candidates in parallel programs. The mathematical warfare had begun in earnest, and German calculations pointed toward only one possible outcome. Excellence would be buried under adequacy. Quality would be overwhelmed by quantity. Precision would be defeated by scale. German officers, trained in traditional military mathematics, struggled to comprehend industrial warfare's new equations. Victory no longer depended solely on tactical brilliance or technical superiority. It required sustainable production, systematic logistics, and replacement rates that could maintain continuous pressure regardless of individual losses. The laughter that had echoed through Berlin conference rooms was dying as German planners realized they were fighting not just an air force, but an entire nation's industrial capacity focused with terrible mathematical precision on overwhelming German aviation through sheer numerical superiority. The first major test of American aviation philosophy came over Sicily in July 1943. Operation Husky would pit German aviation excellence against American mass production for the first time on a massive scale. Luftwaffe pilots, veterans of successful combat across Europe, expected to handle American formations with familiar tactical superiority. Instead, they encountered something unprecedented, not necessarily better aircraft, but more aircraft than they had ever seen filling the skies simultaneously. American formations appeared in numbers that defied traditional tactical response. Where German doctrine emphasized small formations of expert pilots, Americans deployed massive formations of adequately trained pilots supported by overwhelming numerical advantage. The mathematical reality was immediately apparent to German squadron commanders. They could still outfight individual American pilots in direct combat, demonstrating superior training and aircraft performance. But there were simply too many Americans. Shoot down 2 fighters and 4 more appeared. Achieve local air superiority for 30 minutes, only to be overwhelmed by fresh formations arriving from seemingly inexhaustible reserves. German pilots reported frustration rather than fear during initial engagements. Their Messerschmitt Bf 109s and Focke-Wulf 190s remained superior aircraft in direct performance comparisons. Individual German pilots consistently achieved higher kill ratios. The problem wasn't quality, it was quantity at scales that German tactical doctrine had never anticipated. The American approach revealed its tactical genius through sustained pressure operations. They didn't need every pilot to be an ace capable of achieving multiple kills per mission. They needed every pilot to be competent enough to fly formation, follow orders, and contribute to collective effectiveness. Attrition warfare in the air, a concept German planners had never seriously considered. Maintenance logistics told a parallel story of American systematic advantages. German aircraft, damaged in combat, required extensive repairs at specialized facilities using precision tools and factory-trained mechanics. American aircraft, built for field maintenance, could be repaired by ground crews using basic tools and standardized replacement parts. Mission availability rates heavily favored American forces. The Sicily campaign became an inadvertent laboratory for testing American mass tactics against German precision warfare. Fighter sweeps, involving hundreds of American aircraft, created tactical situations that German formations had never trained to handle. Bomber formations, protected by fighter escorts, that outnumbered entire German fighter groups. German pilots began reporting psychological effects that veteran commanders found disturbing. The sound of hundreds of American engines approaching created anxiety responses before combat even began. Pilots who had never experienced fear during years of successful operations found themselves overwhelmed by the sheer scale of American air presence. Radio intercepts captured German pilot communications, revealing growing demoralization. Too many became a recurring phrase in Luftwaffe transmissions. Veterans who had dominated European skies now spoke of feeling hunted rather than hunting. The psychological impact of numerical inferiority began affecting combat performance. One captured German pilot provided insight into Luftwaffe thinking. "We were expecting to fight pilots," he reported. "Individual combat between professionals. Instead, we discovered we were fighting a force of nature. They kept coming in numbers that seemed impossible." The tactical flexibility of American formations surprised German commanders who had studied American doctrine through intelligence reports. Instead of rigid formations, flying predictable patterns, American units demonstrated adaptability that German tactical manuals hadn't anticipated. Italian campaign air battles further demonstrated American numerical advantages. German fighter pilots found themselves consistently outnumbered by ratios that made traditional tactics suicidal. The Finger Four formation that had proven effective against British and Soviet forces became problematic when facing American formations, putting dozens of fighters into the same airspace simultaneously. Ground attack missions revealed another dimension of American tactical evolution. While German aircraft were optimized for specific roles, American fighters demonstrated versatility that confused German tactical responses. The same P-47 Thunderbolts, providing bomber escort in the morning, might strafe German airfields in the afternoon. The attrition mathematics became particularly brutal for Luftwaffe units operating over Italy. Each German pilot lost represented months of irreplaceable training and years of accumulated combat experience. American pilot losses were replaced by graduates from training programs producing hundreds of pilots monthly. German reconnaissance reports from Italian airfields painted a stark picture of American material superiority. Hundreds of aircraft parked in neat rows, with replacement aircraft arriving daily. German airfields showed increasingly empty revetments, as attrition reduced available aircraft faster than production could replace them. By late 1943, Luftwaffe commanders in the Mediterranean theatre were requesting reinforcements that higher command couldn't provide. German aircraft production, while technically superior, couldn't match replacement rates needed to maintain effective opposition to American operations. The laughter that had echoed through Berlin conference rooms 18 months earlier was becoming harder to remember as German pilots faced American air power deployed at unprecedented scales. Nothing prepared the Luftwaffe for the American daylight bombing offensive that began in earnest during 1943. British night bombing raids had been manageable, scattered aircraft operating under cover of darkness with limited accuracy. American daylight bombing was entirely different. Massive formations of heavy bombers, protected by fighter escorts, flying in broad daylight with precision targeting. The Boeing B-17 Flying Fortress embodied American manufacturing philosophy perfectly. Not the most advanced bomber design available, but robust, reliable, and producible at unprecedented scales. Each aircraft bristled with defensive armament, 13 50 caliber machine guns designed to create overlapping fields of fire. German interceptor tactics had been perfected against smaller formations and individual aircraft. Single-seat fighters could pick off isolated bombers through superior speed and firepower. Against American box formations of 20 to 30 aircraft, each bristling with machine guns and flying in tight defensive patterns, traditional tactics proved suicidal. The sight of 300 or more American bombers approaching German cities created panic among both military commanders and civilian populations. The psychological impact was immense. These weren't night raiders sneaking through darkness, but daylight formations flying with apparent impunity over the Reich itself. German fighter pilots faced impossible calculations during bomber interception missions. Each attack required penetrating fighter escort screens that often outnumbered available German interceptors. Surviving concentrated defensive fire from bomber formations that could put hundreds of machine guns into coordinated patterns. Then returning through the same gauntlet, the attrition rates were catastrophic for Luftwaffe units assigned to bomber interception duties. Veteran pilots who had survived years of combat found themselves facing odds that made survival largely a matter of luck rather than skill. Squadron strength melted away under sustained pressure of daily bomber raids. Worst of all was the relentless nature of American daylight operations. British night bombing came in waves, with intervals that allowed German forces to recover. American daylight bombing was continuous. Formations appeared every day, sometimes multiple times per day. German pilots faced combat stress without respite. The industrial targets told their own story of systematic destruction. American bombers methodically destroyed German aircraft factories, fuel production facilities, and pilot training bases. Each successful mission reduced German capability, while American capability continued expanding exponentially. Ball-bearing factories, synthetic fuel plants, aircraft assembly facilities, each target represented months of German industrial investment reduced to rubble in hours. The precision of American bombing, enabled by daylight operations and sophisticated bomb sites, meant attacks achieved maximum damage. By mid-1943, Luftwaffe pilots were reporting that American bomber formations seemed to darken the sky during approach. One veteran ace described looking up and seeing a river of silver aircraft stretching from horizon to horizon. The psychological impact was devastating for pilots accustomed to air superiority. Radio intercepts captured German pilot communications, revealing growing desperation. Controllers directing interception attempts often found themselves coordinating attacks against formations so large that individual squadrons couldn't effectively engage them. Too many targets became a recurring phrase in Luftwaffe transmissions. The defensive firepower of American bomber formations created killing zones that German fighters could rarely penetrate successfully. Coordinated fire from dozens of bombers flying in box formations created walls of steel that made close-range attacks extremely hazardous. Weather operations demonstrated another American advantage German planners hadn't anticipated. Their bombers, designed for reliability rather than maximum performance, continued operating in conditions that grounded more sophisticated German interceptors. German air defense networks, designed around assumptions of limited enemy capabilities, proved inadequate against the scale of American operations. Radar systems became overwhelmed by the sheer number of targets. Anti-aircraft artillery couldn't provide comprehensive coverage against formations approaching from multiple directions. The ammunition expenditure required for effective bomber interception strained German logistics beyond capacity. Each mission against American bomber formations consumed ammunition at rates that German production couldn't sustain. Pilots began reporting ammunition shortages that limited their effectiveness. Training replacement pilots became increasingly difficult as American bombers systematically destroyed Luftwaffe training facilities. Flight schools that had operated safely in rear areas found themselves under direct attack. Training aircraft, fuel supplies, and instructor pilots all became targets. The cumulative effect was a death spiral for German aviation. Fewer experienced pilots meant less effective interception. Less effective interception meant more successful bombing missions. More successful missions meant reduced German production capability. By late 1943, German cities lived under constant threat of American daylight raids. The sound of approaching bomber formations, hundreds of engines creating thunder audible for miles, became associated with inevitable destruction. The laughter that had echoed through Berlin conference rooms just 2 years earlier seemed like ancient history as German commanders watched American bomber streams pass overhead with increasing frequency. The North American P-51 Mustang represented everything German intelligence had failed to understand about American aviation development philosophy. Initially dismissed as crude and inadequate, it evolved through systematic improvement into the aircraft that would break the back of the Luftwaffe. The Mustang's development story embodied American pragmatism at its most effective. Designed in just 117 days, using available components, the aircraft prioritized rapid production over theoretical perfection. Early versions were indeed problematic, plagued by engine issues and performance limitations that seemed to validate German assumptions about American technical incompetence. But Americans didn't pursue initial perfection through extended development cycles. Instead, they embraced systematic improvement through rapid iteration and field testing. Each production batch incorporated lessons learned from previous versions. Problems were solved through engineering modifications that could be implemented on assembly lines. The transformation from flying coffin to war winner happened through continuous refinement, guided by combat experience. Better engines replaced problematic ones. Aerodynamic improvements enhanced performance. Enhanced systems increased reliability, all while maintaining production rates that kept new aircraft flowing to operational squadrons. The game-changing moment came when P-51 Mustangs began escorting American bomber formations all the way to Berlin and back. German pilots, accustomed to limited-range escorts that turned back halfway to targets, suddenly faced American fighters operating over their own capital city. The escort missions revealed the full scope of American air power projection capabilities. Thousands of fighters operating at ranges that seemed impossible by German calculations. The Luftwaffe found itself fighting desperate defensive battles over its own territory against enemies who could apparently operate anywhere with impunity. German pilot accounts from this period reveal growing demoralization that infected even veteran units. They were still excellent pilots, flying excellent aircraft in direct comparisons. But they were systematically outnumbered, outranged, and increasingly running low on fuel, ammunition, and replacement aircraft. The P-51's range capabilities meant German aircraft were safe nowhere within the expanding radius of American operations. Airfields hundreds of miles from combat zones became vulnerable to fighter sweeps. Training schools found themselves under attack. Aircraft factories were strafed by fighters that had flown bomber escort missions. Weather operations demonstrated another dimension of American tactical evolution. The Mustang's reliability, designed into the aircraft from the beginning, allowed continuous operations in conditions that grounded more sophisticated German fighters. Rain, snow, and mechanical stress barely affected American mission schedules. One German pilot's diary entry from early 1944 captured the transformation perfectly. "The Americans are everywhere," he wrote. "We used to own the sky over Germany. Now we rent it by the hour." Radio intercepts revealed German controllers struggling to coordinate effective responses against American formations that seemed to multiply faster than intelligence could track them. Indiana alerts, warnings of incoming American fighters, became so frequent that German pilots began ignoring them. The tactical flexibility of American fighter operations surprised German commanders who had studied American doctrine through captured manuals. Instead of rigid adherence to prescribed tactics, American units demonstrated adaptability that German training hadn't anticipated. Ground attack capabilities added another dimension to American fighter operations that strained German defensive planning beyond capacity. The same aircraft providing bomber escort in the morning might strafe German transportation networks in the afternoon. German fuel shortages created cascading effects that multiplied American advantages exponentially. Luftwaffe units began rationing flight time, reducing training hours, and limiting operational sorties to conserve increasingly scarce aviation gasoline. American fighters maintained continuous pressure that German forces couldn't match. Pilot replacement mathematics became increasingly desperate for German commanders attempting to maintain squadron strength. Each experienced pilot lost represented years of irreplaceable training. American pilot losses were filled by graduates from training programs that produced replacement aircrew at industrial scales. The ammunition expenditure required for effective combat against American fighter formations strained German logistics systems beyond their breaking points. Pilots began reporting ammunition shortages that forced them to break off potentially successful attacks. Maintenance support for German aircraft became increasingly problematic as American fighters systematically attacked repair facilities and spare parts depots. Complex German aircraft required precision maintenance that became impossible under combat conditions. Training new pilots became virtually impossible as American fighters ranged freely over German training areas. Flight schools that had operated safely in rear areas found themselves under constant attack. By mid-1944, the Luftwaffe faced a death spiral that no amount of individual pilot skill could reverse. Fewer experienced pilots meant less effective resistance. Less effective resistance meant more successful American operations. The laughter that had echoed through Berlin conference rooms 3 years earlier was now just a bitter memory as German commanders watched American fighters operate over German territory with apparent immunity. D-Day represented the ultimate validation of American aviation strategy and industrial superiority. The invasion of Normandy succeeded largely because American air power had achieved such complete dominance that German forces couldn't mount effective resistance. The sky itself had become an American highway. The numbers tell the story with stark mathematical precision. On June 6, 1944, Allied air forces flew over 14,600 sorties supporting the invasion. The Luftwaffe managed just 319. German pilots reported that attempting to attack invasion beaches was virtual suicide. American fighters appeared instantly in overwhelming numbers. German ground forces found themselves fighting without air cover for the first time since 1940. The psychological impact was devastating for troops accustomed to Luftwaffe superiority. Veterans of successful campaigns across Poland, France, and Russia now cowered in foxholes from constant American air attack. The tactical flexibility of American air power proved decisive for invasion success. Fighter bombers could attack German reinforcements approaching the beachheads, then switch seamlessly to close air support for advancing infantry units. Transport aircraft delivered supplies directly to advancing forces. The sky had become a three-dimensional battlefield entirely dominated by American forces. German panzer commanders, veterans of successful armoured campaigns across Europe, found their formations pinned down by constant air attack that made coordinated movement impossible. Units that had previously advanced 50 miles per day now struggled to move 5 miles without suffering crippling losses. The Luftwaffe's desperate attempts at response revealed their hopeless situation. Aircraft that should have been defending the Reich against strategic bombing were thrown into suicidal attacks against the invasion fleet. Each mission resulted in losses they couldn't afford, further depleting already inadequate reserves. Most telling was German radar operators' reports during the invasion period. American aircraft filled their screens like clouds of mechanical locusts, appearing in such numbers that traditional fighter interception became mathematically impossible. Individual squadrons couldn't effectively engage formations containing hundreds of targets. Transport operations demonstrated another dimension of American air superiority that German planners hadn't fully anticipated. Cargo aircraft operated routine supply missions to forward airfields constructed by engineer units within days of initial landings. German forces watched American units receive continuous resupply by air. Within a week of the initial landings, German commanders recognized that the invasion's ultimate success was guaranteed by overwhelming air superiority. Ground fighting would determine how quickly Allied forces expanded their beachhead, but not whether they would succeed. The ammunition expenditure statistics revealed the scope of American air operations supporting the invasion. Fighter bombers consumed ammunition and ordnance at rates that would have bankrupted German logistics systems within days. American supply chains delivered replacement munitions faster than combat units could expend them. German communications networks, already strained by strategic bombing campaigns, collapsed entirely under concentrated air attack during the invasion period. Command posts were destroyed faster than they could be relocated. Telephone lines were cut repeatedly by strafing attacks. The contrast in pilot experience levels became particularly apparent during D-Day operations. American formations included many newly trained pilots, but their systematic training programs had produced competent aircrew capable of executing complex missions reliably. German pilots were too few to maintain continuous operations. Weather operations showcased American technological advantages. Their aircraft, designed for reliability under adverse conditions, continued operating in weather that grounded remaining German interceptors. Cloud cover that should have provided protection for German ground forces instead concealed American air operations. Night operations demonstrated the growing sophistication of American air power projection. Transport aircraft delivered supplies during hours when German forces traditionally felt secure. Night fighters patrolled German rear areas, attacking any vehicle movement detected by sophisticated radar systems. The fuel consumption mathematics were devastating for German defensive planning. Remaining Luftwaffe units consumed their scarce aviation gasoline reserves in futile attempts to disrupt invasion operations. Each sortie reduced already critical fuel stocks that couldn't be replaced. German pilot training became virtually impossible during the invasion period. Flight schools that had relocated to supposedly safe areas found themselves under direct attack by American fighters operating from forward bases in Normandy. By the end of June 1944, German commanders understood that air superiority had made Allied victory mathematically inevitable. The question was no longer whether Germany would be defeated, but how quickly American advantages would translate into complete military collapse. The laughter that had echoed through Berlin conference rooms 4 years earlier was now replaced by desperate attempts to develop wonder weapons. But wonder weapons required time, resources, and industrial capacity that Germany no longer possessed. American aircraft had transformed from objects of mockery into instruments of inevitable victory, carrying the industrial might of a fully mobilized democratic nation focused on ending the war. By 1945, American aircraft production had reached levels that defied comprehension. Factories were completing aircraft at rates of one every 5 minutes around the clock. The Willow Run plant alone was producing B-24 Liberator bombers faster than the Luftwaffe could shoot them down, even if German forces had possessed unlimited fuel and ammunition. German pilots facing American formations in the war's final year described them as mechanical thunderclouds that darkened European skies. Formations of 500 or more heavy bombers, escorted by 300 or more fighters, appeared over German targets with crushing regularity that made resistance seem futile. The industrial warfare had become completely one-sided in favor of American production capabilities. America was replacing aircraft losses faster than Germany could inflict them, while German production crumbled under sustained bombing and critical resource shortages. Luftwaffe veterans reported psychological breaking points that veteran commanders found deeply disturbing. Pilots who had survived years of combat against British and Soviet forces found themselves overwhelmed by the sheer scale of American air presence. The sound of approaching American formations triggered panic responses, even among hardened veterans. German aircraft production, which had peaked at approximately 40,000 aircraft in 1944, collapsed to a few hundred per month by early 1945. Meanwhile, American production continued at peak rates, creating aircraft surpluses that allowed for experimental tactics and massive training programs. The final bombing campaigns showed American air power at its most devastating. 1,000-bomber raids that turned entire cities into infernos became routine operations. Fighter sweeps destroyed German aircraft on the ground before they could become airborne. Transport missions supplied advancing armies entirely by air. One captured German officer reportedly said, "We thought we were fighting an air force. We discovered we were fighting an entire nation's industrial output with wings attached." The comment captured the fundamental miscalculation that had doomed German aviation from the beginning. The mathematics had become impossible for German strategic planning. American factories were producing aircraft faster than German pilots could be trained to fight them, even if Germany had possessed unlimited fuel and raw materials. Each day brought hundreds of new American aircraft into operational service, while German strength decreased. Training replacement pilots became virtually impossible, as American fighters ranged freely over German training areas. Flight schools found themselves under direct attack regardless of location. Training aircraft, fuel supplies, and instructor pilots all became priority targets for American air operations. The fuel crisis reached catastrophic levels that made sustained air operations impossible for German forces. Remaining Luftwaffe units were grounded not by enemy action, but by complete lack of aviation gasoline. Synthetic fuel plants lay in ruins. Even captured fuel was insufficient to maintain minimal operational capability. German radar networks became useless against the scale of American air operations. Operators reported that their screens were completely saturated with targets during major operations. Individual aircraft tracking became impossible when hundreds of formations approached simultaneously from multiple directions. Anti-aircraft artillery couldn't provide comprehensive coverage against formations that could approach German targets from any direction. Ammunition shortages forced gunners to conserve shells for the most critical targets, allowing most American aircraft to operate with minimal interference. The psychological impact on German civilian populations became as devastating as the physical destruction. The constant presence of American aircraft demonstrated German military impotence more effectively than any propaganda campaign. Citizens watched endless streams of enemy aircraft operate with apparent immunity. Weather advantages that had historically favored defending forces were neutralized by American aircraft designed for reliability under adverse conditions. Operations continued in rain, snow, and mechanical stress that would have grounded more sophisticated German interceptors. Night operations extended American dominance into hours when German forces had traditionally felt secure. Transport aircraft delivered supplies during darkness. Night fighters patrolled German territory using radar and infrared detection systems that German technology couldn't match. Maintenance support for remaining German aircraft became impossible under continuous air attack. Repair facilities were destroyed faster than they could be relocated. Spare parts production ended when factories were bombed. Complex aircraft remained grounded for want of qualified maintenance personnel. German communication systems collapsed entirely under systematic air attack. Command and control became impossible when headquarters, telephone exchanges, and radio stations were destroyed faster than they could be replaced. By April 1945, German commanders understood that continued resistance was militarily impossible. The industrial and numerical advantages that American air power represented had made German defeat a mathematical certainty. The laughter that had echoed through Berlin conference rooms 5 years earlier was now just a bitter memory as the Third Reich collapsed under the weight of American industrial production focused on achieving complete military victory. American aircraft filled European skies as symbols of democratic industrial power triumphing over authoritarian military tradition, carrying the collective will of a nation fully mobilized for total victory. The same German officers who had laughed at American aircraft in 1940 lived to see Berlin's skies filled with thousands of American bombers and fighters operating with complete impunity. Their initial mockery had transformed into one of history's most costly miscalculations, a cautionary tale echoing through military academies for generations. Post-war interviews revealed the depth of German misunderstanding about American industrial capabilities and strategic thinking. They had focused obsessively on individual aircraft excellence, while Americans had revolutionized aviation warfare through systematic superiority. Quality versus quantity represented fundamentally different philosophies about modern technological warfare. German aviation had indeed produced magnificent aircraft that represented pinnacles of engineering achievement. The Messerschmitt Me-262 jet fighter was years ahead of anything America fielded during the war, but Germany built fewer than 1,400 Me-262s during the entire conflict. America built over 300,000 aircraft in 1944 alone. The lesson extended far beyond aviation into fundamental questions about military strategy and industrial planning. German military thinking had emphasized elite excellence, small numbers of superior weapons operated by highly trained specialists. American thinking emphasized democratic effectiveness, large numbers of adequate weapons operated by competently trained masses, achieving victory through overwhelming scale. Both philosophies had merits under ideal conditions that rarely existed in actual warfare. German aircraft were individually superior in most measurable performance metrics, but war isn't fought under ideal conditions with unlimited resources and perfect logistics. War is fought under constraints of industrial capacity, training time, fuel availability, and replacement rates that favor different solutions than peacetime competitions might suggest. The most sophisticated weapon means nothing if it cannot be produced, maintained, and employed at necessary scales. The mathematical implications had been visible to those who understood them from the beginning. Each German aircraft lost represented months of irreplaceable skilled labor. Each pilot killed required 18 months of intensive training to replace, assuming replacement was possible given shrinking resources. American aircraft losses were replaced by production lines operating continuously. Pilot casualties were filled by training programs graduating new aircrew weekly, using systematic instruction methods that emphasized consistency over individual brilliance. The laughter that had echoed through Berlin's Air Ministry in 1940 became a cautionary tale about the dangers of underestimating different approaches to similar problems. The Germans had looked at American aircraft and seen crude simplicity where they should have recognized scalable effectiveness. Modern military planners still study this dynamic when evaluating competing weapons systems and strategic approaches. The tension between individual excellence and systematic capability remains relevant in everything from aircraft design to cyber warfare capabilities. The story's broader implications transcend military history and speak to timeless patterns in technological disruption and competitive strategy. Innovation often appears crude to established experts who mistake complexity for capability. Disruptive approaches seem inferior until they achieve scales that make traditional comparisons irrelevant. The German generals who laughed in 1940 had made the classic error of fighting the last war while their enemies were preparing for the next one. They had perfected the aviation equivalent of cavalry warfare, while Americans were building the aviation equivalent of industrial-scale firepower. Individual excellence lost to systematic adequacy, when systematic adequacy could be deployed at scales that made individual comparisons mathematically irrelevant. The most beautiful aircraft meant nothing when facing hundreds of adequate aircraft supported by inexhaustible replacement capability. Their confident mockery would echo through history, not as validation of German technical superiority, but as warning about the dangers of underestimating enemies who were playing entirely different strategic games. The Americans weren't trying to build better airplanes than Germans. They were building more airplanes than Germans could possibly shoot down. The final irony emerged in the post-war period, when many German pilots who survived the conflict emigrated to America, where they worked in the same aviation industry they had once dismissed as technically inferior. They had learned, too late, that effectiveness in warfare comes not from theoretical perfection, but from practical application at sustainable scales. Asked years later what symbol best represented American victory over German aviation, one veteran Luftwaffe pilot didn't mention advanced technology or superior training. He mentioned the simple sight of American aircraft everywhere. They were like a force of nature, he said, individually ordinary, collectively irresistible. The lesson resonates beyond its historical moment, because it speaks to fundamental truths about innovation and competition. In war, as in many endeavors, the perfect solution is often the enemy of the adequate solution deployed at decisive scale. The German officers learned too late that when change comes in humble forms, the wise response isn't laughter but careful attention. For in that humility often lies the seed of revolution that will reshape entire industries and alter the course of history itself.